Hi, welcome to my channel. How do you solve this integral? So we can recognize that this integral is, the integrand is an even function. In that case, we can rewrite our integral as the integral from 0 to the upper limit 2, but 2 times of that of x squared divided by 1 plus x squared plus the square root of 1 plus x squared dx, because the integrand here is an even function. So we can do a substitution here. We can let x to be equal to the sine hyperbolic of t. So the x is going to be the cosine hyperbolic of t dt. That is the differential of the sine hyperbolic of t. So the change in limits, when x is equal to 0, you have t to be equal to the sine hyperbolic inverse of 0, which is 0. When x is equal to 2, t is going to be the sine hyperbolic inverse of 2, which I will leave it as it is. And then I'm really going to use some identities here. You know that the cosine hyperbolic square of t minus the sine hyperbolic square of t is equals to 1 from the hyperbolic functions. So from here, we have the cosine hyperbolic of t is 1 plus the sine hyperbolic square of t. So we can really now at this point take our integral from the x world into the t world. So I is going to be 2 times the integral from 0 to 2, but it's now going to be 2 times the integral from 0 to the sine hyperbolic inverse of 2 of x squared. X is sine hyperbolic of t by a squared divided by 1 plus x squared, which is sine hyperbolic square of t plus the square root of 1 plus sine hyperbolic square of t times dx, and dx is cosine hyperbolic of t dt. Run out of room here. So I is going to be 2 times the integral from 0 to sine hyperbolic inverse of 2. And sine hyperbolic square of t, from here, I can write that as cosine hyperbolic square of t minus 1, which is the sine hyperbolic square of t. I will just replace that in the numerator. So this is cosine hyperbolic square of t minus 1 divided by this one. I can write that one as cosine hyperbolic square of t plus the square root of cosine hyperbolic square of t times cosine hyperbolic of t dt. So I is going to be 2 times the integral from 0 to the sine hyperbolic inverse of 2 of the numerator. Can also be written as this because it's a difference of 2 squares times the cosine hyperbolic of t plus 1. That is the difference of 2 squares in the numerator. This is cosine hyperbolic of t in the squared plus the square root of that is the cosine hyperbolic of t times cosine hyperbolic of t dt. We are almost there. So I is going to be 2 times the integral from 0 to the sine hyperbolic inverse of 2, then cosine hyperbolic of t minus 1 times the cosine hyperbolic of t plus 1 divided by cosine hyperbolic of t. Factorize that one out and I have cosine hyperbolic of t plus 1 times cosine hyperbolic of t dt. Now a lot of be some cancellations here. So a lot of cancellations, this will cancel that and this will cancel this. So in the end, so you are just left with the integral from 0 to sine hyperbolic inverse of 2 of cosine hyperbolic of t minus 1 dt. Nice. So we are now going to integrate. Integrating this is the sine hyperbolic of t minus t. And your limits are from 0 to the sine hyperbolic inverse of 2. Nice. So I is going to be 2 times. You now plug in your upper limits. I'm sorry about that. we plug in your upper limit, that is going to be sine hyperbolic of the sine hyperbolic inverse of 2 minus the sine hyperbolic inverse of 2. That is your upper limit minus your lower limit. You plug in 0, which is sine hyperbolic of 0 minus 0, like this. Okay, so I is going to be 2 times sine hyperbolic and the sine hyperbolic inverse of 2. This and this will sort of like cancel, then we have 2 minus the sine hyperbolic inverse of 2 minus this is 0 and that is 0. So everything is 0, so we are good as it is now. We have to know that this one sine hyperbolic inverse of x can also be written as the natural logarithm of x plus the square root of x squared plus 1. So that implies that the sine hyperbolic inverse of 2 is going to be the ln of 2 plus the square root of 2 squared plus 1, which is the ln of 2 plus the square root of 5. So we just plug that into our answer. We can stop here, but this is just a simplification. So I is going to be 2 times 2 minus the ln of 2 plus the square root of 5, which simplifies to 4 minus 2 ln of 2 plus the square root of 5. So, ladies and gentlemen, this is the answer to our integral. Therefore, if we integrate negative 2 to 2 of x squared divided by 1 plus x squared plus the square root of 1 plus x squared dx, this one evaluates nicely to 4 minus 2 ln of 2 plus the square root of 5. So this one is the value of our integral. So if you really find this helpful, please subscribe to my channel, smash the subscribe button for more engaging tutorial from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.